Okay. I want to take something that intuitively seems like it might be true and see if it really is. Generalizing number 4013.1, where you have the vector xi plus yj plus zk. You cross that with any constant vector, and you get zero divergence. Now, I'm thinking that that has to be true for any radial vector, not just xi plus yj plus zk. So we want to see, because when you cross any vector with the radial vector, you're going to get a vector perpendicular to the radial vector. So that the flux, and I'm thinking ahead, the flux through any sphere would be zero, because the vector is always, the cross product is always perpendicular to the radial vector, so it doesn't penetrate the sphere. It's always perpendicular to the normal to the sphere, always parallel to the sphere. Anyhow, get to that later, but that's what kind of drives my intuition on this. So let's see if this is true. So intuitively, A cross R is perpendicular to R. So R radial implies A cross R is tangent to any sphere centered at the origin. Okay, well, let's just see if this holds up. So let's let R be a general radial vector, just g of xi plus g of yj plus g of zk. And well, yeah, let's go on with it. It doesn't seem like it's going to be true, even radial for any arbitrary g. Let's work it out and see for what g's this might be true, if it doesn't work for just any g. Okay, so A cross R, and we'll go ahead and use a determinant. I like to use a distributive law, but in this case, the determinant is more convenient. So we have this, which is I times B g of z minus c g of y plus j on j times c g of x minus a g of z plus k times a g of y minus b g of x. Okay, so there's our cross product. So the gradient, just write it up here, very straightforward. The gradient of A cross R is what? It's I times B g prime of z minus cg prime of y plus j times cg prime of x. Wait a minute. It's going off on a non-mathematical tangent. Kind of ridiculous. Okay, it's I times the partial with respect to x of all this stuff, and all this stuff is 0 because g of z and g of y are both, neither has an x dependence. So okay, well, this is 0. It's an obvious, e.g. partial with respect to x of b g of c minus cg of y. B and c are constants, is b times, I'll write gx of z minus c gx of y, and that's 0, because g of z is a function only of z, no x dependence. Same with g of y. Both of these are constant with respect to x, in case I needed to say that. So my intuition is at least partially vindicated, and we'll see how this applies. So, you know, this is a radial vector. I mean, yeah, don't need to elaborate on that. Okay. So the problem as given was just xi plus yj plus zk, but this apparently does generalize.